In the autumn of 1941, Swiss engineer Georges de Mestral went for a routine walk with his dog through the brush of the Jura Mountains. When they emerged, both de Mestral's wool jacket and his dog's coat were covered in burdock burrs, small prickly seed cases that gripped tightly to anything fibrous they touched. For most hikers, these burrs are a mild annoyance. You stop, peel them off, drop them on the ground, and move on without a thought. But instead of discarding them, de Mestral kept the burrs. This choice, to investigate rather than ignore the nuisance, turned a common mountain walk into the starting point for a global manufacturing standard. Later that evening in his home laboratory, de Mestral placed one of the burrs under a microscope to see how it worked. Under magnification, the burr revealed a complex architecture. It relied on hundreds of stiff extensions ending in tiny curved hooks. When pressed against wool or fur, these hooks snag and lock around the fabric's flexible loops, creating a secure mechanical bond. Nature had designed a temporary, reusable fastener. De Mestral had the blueprint, but he now faced a massive engineering challenge. Could human manufacturing replicate this microstructure? It would take 8 years of constant trial and error to move from that initial observation to a functional prototype. The primary bottleneck was scale. Industrial looms were designed for flat textiles, not for weaving thousands of three-dimensional geometric hooks at a microscopic scale. Early tests with cotton were a failure. The fiber was too soft. Any hooks woven from it would collapse under pressure and lose their grip. Wool was equally problematic. Its natural irregularities made it nearly impossible to produce a consistent, reliable field of receiving loops. The mechanical concept was right, but execution was stalled by the structural limitations of natural fibers. In 1948, de Mestral took his challenge to a textile mill in Lyon, France, partnering with a weaver who specialized in industrial fabrics. They found their solution in a new synthetic thread, nylon. Unlike natural fibers, nylon could be used to permanently hold a rigid shape at microscales. The manufacturing breakthrough involved weaving nylon into dense loops and then cutting them. When snipped at a precise angle, the loops would snap upward to form rows of durable, springy hooks. In 1951, de Mestral finally named the product by combining the French words for velvet, velours, and hook, crochet, to form Velcro. The natural mechanism of the burr had finally been translated into a reliable, mass-produced reality. Over the following decades, the fastener moved from a specialized textile experiment to a standard component in modern manufacturing. It is now ubiquitous in domestic life, allowing children to secure their shoes quickly without needing the manual dexterity required for laces. In orbit, it performs a critical role aboard the International Space Station, securing heavy equipment and tools in a zero-gravity environment. Regardless of the setting, the mechanical interaction is always the same, a direct replication of the burr's original design. Every application relies on that singular physical action, a firm press to engage the hooks and a definitive tear to release them. The invention serves as a reminder that significant innovation often starts with a simple observation, if someone has the patience to investigate what others ignore. The billions of fasteners used in everything from surgical bandages to space station cargo trace back to that single walk and an engineer who looked at a mountain nuisance and saw a mechanism.